Okay, so I'm going to do a quick demo on the homework assignment number 3, and then I will open the floor for you to ask some question as well. So let me first go back to the slides. I just want to tell you that I think this slides, I kind of summarize what's happening. Let me turn on this slide very quickly. This is the okay. So this is a slide that when you untar the tar file that from this link, what you will get is this set of file. There's a lot of .cpp and .h file, and also you have a make file, you have a JSON file. So the make file is essentially following this flow of dependency relationship. So the blue was triggered by the JSON CPP stub program to generate those two .h file. And the green arrow were followed by the compiling process, which they will need, the .cpp file need to include the .h file in order to produce the .o file. And then finally, the HW3 server, HW3 client, and the red links represent the linking. So it's linking all the .o file together to generate this two executable. So this gives you an overall picture about what makefile is trying to follow. It also gives you what is the content of those files and how they're related to each other. Okay, and I assume you, if you haven't read the see the newest tape, that lecture number 6 essentially talks about the tar file and talk about how to utilize inheritance and also polymorphism like a virtual function to implement this hierarchy: the core object, person object, transaction flight, and shadow flight. So the server is essentially implemented at the flight level, where the client is actually implemented at the shadow fly level. Okay, so now I'm going to my terminal screen. Let me make my window a little bit smaller so you can see the whole thing. A little bit smaller. Okay, I'm going to do a make clean first. So when you untar the file, you're going to see all this file in front of us. Okay, you have core CPP and H, you have person CPP and H, you have a transaction CPP and H, and then you have a shadow flight CPP and shadow flight.h, and then you have this two HW3 client, HW3 server, and then of course you have the make file to put things together. And the important thing is about the JSON file, which you start to experience how to use this JSON file in the part 1 of homework assignment number 3. So now I'm actually designing a kind of JSON file just for illustration. This tar file is for you to get familiar with how you can put all these pieces together, and then you need to extend this to work on homework assignment number 3. By the way, this is just your reference implementation. It's self-contained. It can do pretty much everything related to that particular call, get distance I implement. So I'm going to show you how to do this, and then you basically use this idea to develop your own. You can change basically everything you want. You want to change, you need to change, by the way, the JSON file, because this current JSON file only implement one call. You might want to have a multiple call, and you have to implement the different type of client server, and then you might want to even extend it from the transaction and person CPP to implement some of those functions. Okay, for example, you want to do if you go back to the homework assignment number 3, you see that there are 3 things I want you to do. The first thing is calculating the distance, which is to get distance involved on the fly. That's great. But the second one is actually a person object, whether they're identical, the COI, then you probably need a shadow person in order to implement that. And then you're going to implement a different function of the fly with a COI situation, which now you, instead of just doing a get distance, you might want to extend shadow fly to actually handle the conflict of interest call as well. So you can see that you need to change here and there. I want to give you the complete control. I mean, after homework assignment number 2, you were kind of constrained to use the code for 1 and 2, but now you're really free to do whatever you want and to demonstrate a client-server scenario that fulfill these 3 things, okay? All right, so, so of course, one thing you should notice that I haven't have any HW3 client.h or HW3 server.h. Those are not being created because I haven't executed the JSON RPC stop program. But let's take a look at JSON file. So this JSON file I kind of create as a generic. And the thing is that this name should have been get distance. It should be a different name. Every function should have a 1 of the name. So this is actually, this section is just representing one particular function call. So if you want to do, say, a overloaded operator person comparison, you need to define a different name. You want to do conflict of interest, you need to do a name. But this basically specifies one call and what kind of parameter or argument you need to put in with that call, and such that you can communicate with a remote, okay? All right, so let me just take a look at the, let me actually just type in make first. If you type make, you start to seeing things get compiled. Okay, so it start to ask you, following the picture I show you on the PowerPoint slides, it compile core, it compile transaction, compare person, and then this line is actually start to call the JSON RPC stub, which is generating the HW3 server.h and HW3 client.h. Have you noticed that this is the input is the JSON file I just showed you? All right, so let's take a look now. Now the difference, you can see that now you have HW3 server.h got generated and HW3 client got generated. Those 2 are generated by the JSON RPC stuff. And it has the very interesting side. Let's just take a look. Let's take a look at the client side. This is what it has. So, so this file essentially is include the client side of JSON RPC CPP include file. And it basically create a class specifically for this particular JSON. It's called HW3 client, and it's inherent from the scope of JSON RPC : client. So they're using inheritance, just basically loaded with this. And just go over this now. This is a function we're going to see because this is a call. This is a name is specifically generated for us because the action that I have in the, let me actually just go over here. if you take a look at this, this one is saying the name is ECF36B. So that's why this function says ECF36B here as well. Okay. So let me actually just change this to show you what you can make a difference. So I'm coming here. If I modify this, can I change to get distance? Okay, assuming I change that to another name that I like. And now if I come back here, okay, remember this part says JSON colon value ECF36B HW3. And if I run make again, you see that oh, there's an arrow. Oh, because I changed the name, so it doesn't have that. Okay, but because the name is changed, so now it's running this line again. And so now if I do more HW3, now you can see the function generate is no longer ECF36B, is get distance. So now it's generating the function that according to what I want to do. Of course, you will see that syntax error because now I changed the function name. So the server or the client try to connect, they cannot connect because now the member function is not found, is because I changed the name already. So you can see that this piece of code is generated. You control this piece of code by controlling the JSON, not come here to modify this code. Okay, so that's just demonstration your flexibility to do certain thing. But the important thing is that now I'm going to change this back. I'm just changing a name, which is to demonstrate the idea. Now I change it back. Now I can do make again. Now they're happy because everything is compiled. Okay, so so now the other part I do want to show is that, okay, I was showing you the HW3, this is generated, and then there is a function called ECF36B HW3 is the method that the client is going to call. So who is going to call this? That's what I'm going to show. So the function is going to call this is CPP. Its code is already included in the tar file. It's HW3 client.cpp. So inside the HW, no, sorry, I will okay, no, it's actually should be in I think it's in shell fly.cpp. Yeah, this is, sorry, it's actually calling from my shadow object. So shadow object has a virtual function called getDistance inherited from the fly class. And inside the shadow object, when they receive somebody call getDistance, that it basically just call my client.ecf36b HW3. So this name will direct that to that getDistance function. Okay, so that's the function name you want to get it to call. And then this function, of course, shadow object getDistance was actually called from HW3 client. Over here, it will call this function here. Okay, so now I'm going to show you the how to run this program. Okay, let me get back to my HW3 client CPP. I'm only implement the getDistance in this demo. So I'm going to comment out the last two because this is my version. What you have in your tar file only have the first two, but you can easily add the third one. Okay, so the first two essentially just create two objects. Two objects, one, both of them are fly, but both of them are remote. So so I'm going to go to my server side. So this is the same directory, but I'm going to run my server. But I want to show you, let me first run the program, then we will see the server side. So I actually run the server. This is my local machine. So now I construct a bunch of objects. Particularly, I construct 3 fly, maybe one one transaction object, two fly object. So the object is already running on in this program. So now I want to use the client to call the member function in the server side. Okay, so you can see that now the server has two flight object, but I want to, in order for me to call that from the client side, I will just define this as a shadow fly. I mean, you understand what's the difference between shadow fly and fly. You try to understand what I presented in homework from lecture number 6. Okay. So in order for me to call the remote object, I need 4 arguments. And the first argument is a URL. URL basically is a HTTP path plus a port number. And also the second one is VSID. The third one is the name of the class, the C++ class. And this is the object ID I assign for every single object. That this 4 parameter were all defined under core.h, which is a core object. So basically every single object, because they inherit from the core object, they all should have this 4 parameters, okay, as their identification. So after I create, I can actually now just call this function. I create this F3, and then I actually call the get distance. And then, or F2, I call F2 get distance. Let's actually see how it runs, okay? So just, okay, let me control C. I would just say HW3 client. Okay. Oh, I haven't compiled, sorry. To compile because I removed the last one. Okay, so you can see that now I called it twice, right? And the first one I got a return, the result is 19937, this beautiful number. The second one I actually got it back with this number. Okay, they're both actually giving me the answer. And from the server side, you see that it's actually getting a response. Say, hey, somebody tried to call get distance, and somebody give me from this particular ID. Okay, so you can see that they're communicating. All right, so I'm going to show you the server side now. How do I implement the server? HW3 server. Okay, the server part is a lot more complicated. Of course, it has this my HW3 server, and it inherits from the server generated by the one of the include file from HW3 server.cpp.h. And I inherit from that, and then I basically have this function inside because I have this name. This is function. Remember, I changed that to get distance, and I got a compiler error because you have to put it in yourself. This is manually. This is not being generated, so you have to put in to get this. And then now here's a main body of the function, and this is my implementation about that function I just defined. Okay, so this is the tricky part because for every function you want to implement, you need to have this. So this is a remote proxy connect to your real object. So let's see what happened I implement here. So this has multiple argument coming in. So what I check is, first I check if the class ID is equal to flight. If it's equal to fly, I want to check whether this object ID is equal to 002 or 003 because I only have 2 objects. I want to know which one is which. And then what I will check is that if I couldn't find it, then I know this is a fail, this is error. And well, if it's match, then basically it will say, okay, if the object is this, I will call F2 dot get distance. If the object ID otherwise is 03, I'm kind of hack it because I only have 2 objects, the case 1 and case 2. If it's case 2, then I just call F3 dot get distance. Okay, that's how I get the result of the D from your homework assignment number 2, part 2, and just shovel it in over here and send it back. So I construct the JSON string, and then this part of the code is just try to send it back. So where did I send it back? This part is all construct about JSON. This is reader parse. Okay, no, I didn't send this back here. Let me see. Read character, read character. Okay, I return it. It's probably here. I send it back. Okay, so this part, sorry, I have to go back a little bit. Okay, you see that when you return this value, it's return a JSON value. And that return JSON value, because it's get called by the JSON RPC system, the library. So when you return that, the JSON RPC will immediately send it back from their protocol. So it's that particular send back action is not even in the code that we need to worry about. So it's automatically if you actually inherit from the HW3 server. Okay. The other thing I want to show it to you is that it's actually in the bottom of the main program. So you can see that the main program looks like really like essentially I'm just picking up the code from homework 2, part 2. The main function, you can see I create the GPS, I create the IP address, I create 2 person, I create 1 transaction, and the 2 fly, okay? And so flight 2 is this piece of code is just like you're writing your code locally. And then I'm just basically calling this function to call the server, and then I just listening. Whatever remote coming in, then I'm going to trigger my JSON RPC stuff. Okay. All right, so let's actually just continue. So I have to run the program here. Let me just run it again. And if I run it, okay, I get the same result because it's the same program. Now I got 2 of this. If I stop, server is not running. If you run it, it will say connection error because the server is not responding. Okay, but let me just tell you that some of the things I can show you is that what happened if I do this. If I change the code, instead of 003, I change to 004. And instead of fly, I'm actually changed to transaction, which means that you're actually getting something mismatch with what server is trying to develop. So now if I run the client, you can see that I got some error. So number 1, it says that this particular object 0004 unknown because I don't have it. I only have 002 and 003. So you try. This is like almost like when you use web browser, you got a 4 errors. This or whatever error the file doesn't exist. Or the second case is that you try to get a transaction, but my remote object only support fly. So if you tell me that the class transaction, it will fail as well. Okay, so this is just let you know that it's matching between the client and server here and there. So I'm going to change it back to 3 and change this to flight. Okay, so but I'm going to actually now doing a more interesting study. I'm actually going to simultaneously using 1 client program to contact 2 different servers. So now you can see that I contact 2 different servers. One of the server is on the local host, the one we just connecting to, but the other server is on Cyrus. Okay, the same port number. By the way, you can set out the port number whatever you like. And then I call it F2 remote, okay, F2R. And then I can run this program, but I need to compile. And if I run it, okay, the first 2 are there, but the third one is rejected because I haven't started my server on Cyrus. So now let's actually go to Cyrus. Bad idea. Okay, the same thing. Let me just do a make clean and make. Okay, this is Ubuntu environment. So now I'm actually going to HW3 server. So once I started, now I can run the program again. Now you see I'm getting all three of them. Okay, these two are from HW, this local, so it has two more entry, but also the third one is actually getting from here as well. Okay, so now I have this very interesting situation. I can write the one program. It looks like I'm just touching three objects locally, but in fact, I'm touching two different machines. Okay, I can actually make things even more interesting, say, because this one, let me actually change the server code here. Okay, that's very strange. The internet is, let me see if the program still compile, because there's some funny character. Okay, so I'm going to actually change this part, the program a little bit. The network speed is so slow. Wow. Yeah, this is unpleasant. The internet is from my home to my SSH is not very happy. Okay, so I'm going to create a flight 4. And my, assuming my ID is still the same, but I'm going to create number 4, and then this is going to be from, let me see, this one should be from Sydney to Davis to New York. Sydney to back to Davis. Okay, I'm going to create this one. So now you see that I have a flight number 4, and also I want to do this part as well. F4 is equal to M flight 4, but I also need to set a pointer because I need to use this as my trick to pass the object pointer to another program. So okay, now I have a flight 4. Now I'm going to actually check here. Okay, oh wow. All right, I have to do something crazy. Sorry, this is my hack. So bad software programming here. Object ID. not equal to 1, 2, 3, 4, 1, 2, 3, 4. Okay, let me just check, make sure I close all. Okay, good. All right, if I have this is 0, 4, now I'm going to do this. Else, if this is equal to 3, I'm going to call this. Else, I'm going to call 4. Okay, so I'm just creating another object like this. All right, let's see if it compile. Okay, it compiled. So I'm going to run the server again. Okay, I run the server, and let me restart the server. And over here, I'm going to do something new. I'm going to change this to F4. So essentially, F2, F3, I'm getting from local, but F4, I'm going to getting from a different location. All right, so now I can just say F4. And make. Okay, if everything happened correctly, I should get 3 different. Okay, now you can see that I got 2. This is the original 2, F2 and F3, 99,37 miles, 2515 miles. And the number 3 now, this is from Sydney back to Davis, is 7482 miles. And then now look at the other 2 window. This is at the window from the local, the first server. So it has 2, and the third server actually has 1. Okay, so that's kind of, you can see that I just want to show you for this one function call called get distance, that I can implement the style of shadow object locally, so I can do this what we call remote object invocation, method invocation, RMI, such that I actually really call the method in the C++ object in a different location. Okay, so I'm going to stop here. Any question about what I just did? I saw there were 34 comment on the chat, but I couldn't see it now. But any question, please just use your mic. Are you still there? Wow, it's silence. I must did a horrible or perfect job there. Okay, so what I'm going to do, I'm going to stop the recording first, because I want to make like a 2 separate recordings. So one for the question, one for the demo. Okay, so let me try to